Guys, welcome back. And in this lecture module, we're going to be talking about benzene yet again. Just when you think that you are out of the briar patch with benzene, guess what? I'm going to hit a 1-2, and I'm going to come back and we're going to talk about something that we refer to as dye-substituted benzenes. Well, here's the little secret. We're not just going to stick with the dye-substituted benzenes. We're actually also going to be talking about tri-substituted benzenes. Can you believe it? They get even more complicated. But don't freak out. This lecture material is not going to be a problem at all. If you can make it through the benzene lecture module and you feel comfortable with that, you feel okay with those types of reactions and the nomenclature that we presented in that module, then you will be perfectly okay here as well. All right. Now, let's do a little bit of review. Before we go further in this lecture module, I just want to go back and review a couple of things. And number one, in order to do well in this lecture module, you're going to have to know what the structure of benzene is going to be. What is the structure of benzene? Well, it's this six-membered ring, Tracy, with a double, single, double, single, double, cause you trouble bond. All right, so double, single, double all the way around, and it alternates, and it's flat, and each carbon has an sp2 carbon, and there's an alternating double, single, double all the way around, so the entire thing is hybridized. And we talked about this concept of the delocalization that can happen in the ring. And that leads us into the definition of an aromatic compound. All right, so we've talked about aromatic compounds. We gave you a few examples of aromatic compounds, and this is a true aromatic because there are an odd number of double bonds that are present, or pi electron sets. All right, so there's 3 that's represented in benzene. Now, if there wasn't an odd number, we are close to aromatic, but we're not quite at aromatic. And this is something that we call an anti-aromatic molecule. So all of these are just review terms, something that we talked about in the last lecture module. We're going to be talking about them again throughout this entire lecture series. So why not bring them up and do a nice, clean little review? All right. The other thing that we also discussed was nomenclature, right? I mean, we talked about how to name these things. So if we had a benzene ring and the shorthand notation is just the circle, and I put a Br on here, we said that we name the substituent bromo and then benzene. It's as easy as that. So if we had a benzene with a Cl on it, this would be called chloro, and benzene would be the name. I also need to make it clear, because some people always ask this question, well, what if the substituent is not to the right, up to the top? Well, it doesn't matter. I could draw the bromo down here, and it's still bromobenzene, right? There's not a big deal. All right, well, what about the chloro? Can it be somewhere else in that one little spot? How do I name it like this? Well, you name it the same way. It's still chlorobenzene. There's no difference here, because if there's just that one group, no matter where that group is located on the ring, it will automatically get spot number 1, no matter where you put it. All right, well, we also had a benzene ring with maybe something like NO2 on it. Well, what do we name that? Well, the NO2 was called nitro, and then we added on the word benzene. All right, so those nomenclature rules are going to come back. We're going to revisit them. We're going to reuse them over and over. At the same time, we also talked about a couple of different structures for benzene that were common names. Now, on this slide, this came straight from your textbook, by the way. There is a problem, and the problem is benzaldehyde. So benzaldehyde is not this structure. That is wrong. That is a typo. The textbook can be wrong sometimes. Who would have ever thought? All right, well, what is benzaldehyde? Well, benzaldehyde is a benzene ring. So that's where I'm going to start there. And it's an aldehyde group. So they got close, but no cookie for me. So that's a C double bond O with an H. not an OH. So this is wrong for benzaldehyde. Now, in your current edition, they could have fixed this problem, but if you are using one of the older editions of the textbook, this is a wrong structure that's assigned to that name. Well, that's what we get when we let graduate students review the textbook information. What? Graduate students? We don't get professionals? Well, yeah, we get professionals too that's supposed to teach this stuff, and they missed out on it as well. Well, everybody can make mistakes. So what they did is that they replicated this C double bond OOH, and they used it for benzaldehyde, but they also used it for benzoic acid. Now, benzoic acid, that is correct. It is C double bond OOH, but here it was just a misprint. That oxygen needs to be gotten rid of, and this is a C double bond OH for benzaldehyde. All right, so here are the common structures for benzene that we've discussed. Toluene, phenol, aniline, benzene sulfonic acid, anisole, styrene, benzaldehyde, benzoic acid, and benzonitrile. These structures, I told you that you have to memorize. And the reason is because they're very common structures in the benzene world. We never really want to lose them. And it's going to become important in the nomenclature of di-substituted benzenes as well. So we're going to be using some of these names that we have discussed already up to this point when we go and name di-substituted benzene groups. All right, so let me give you some examples, right? The best way to learn organic is to do examples. So let's do some examples here, and I'll show you how easy this is going to be. All right, so let's take a benzene ring, and on this benzene ring, let's put a bromo. Okay, how would you name it? Oh, well, we just did this. He's trying to trick me. So I would look at this and I would say this is called bromobenzene. Ding, ding, you're correct. All right, well, what if I slapped another bromo on here? There's two groups, right? Two groups, one group here, one group there. Di-substituted. Get it? That's what we're talking about. That's it. Di-substituted benzenes just means there's two things on the benzene instead of one. So how do we fix this problem? Well, there's two bromos, isn't there? And because there's two bromos, the word for two that you've always used is di. So dibromobenzene. But we're not yet done because I have to give it numbers, right? I'm treating this just like a main chain. I have to give you numbers of where those two bromo groups are going to be. I can't just call it dibromobenzene and you know exactly what I'm talking about, because guess what, folks? The bromo could be here and there. Okay, well, that's different than where it is right now. Or the bromo group could be over here, or the bromo group could be there, or the bromo group could be there. So I can't just leave it as dibromobenzene. I've got to give you numbers of where these substituents are going to be located. So these both are equal, folks. One does not win out on the other one. So just start at 1, right? There we go. We call that carbon number 1. And now I'm going to number around the ring to get closer to that other group. So that means I don't want to number left-handed. That would be silly, right? I don't want to go left-handed and around because that will give me a higher number. I want to start here at the top, in my case, number 1, and I'm going to do number 2 is there and number 3 is there. So at spot number 1 and at spot number 3, I'm going to have 2 bromo groups on the benzene ring. So 1, 3, dibromobenzene. All right? So that's how we would name that group. All right, well, let's try it again. Let's say that we have this benzene ring, and we have a Cl here and a Cl there. Okay, how would we name this? Well, both groups are equal again. We're starting off very easy. We're going to baby step into this, right? So I've got a group here and a group there. It is a di-substituted benzene because of that. So it doesn't really matter where I start. They both are equal. They're both the same group. So let's just start down here at number 1. I can do that. I can do whatever I want. That's the freedom of organic. The only thing that I can't do after this point, when I identify which one my first one is I should not go clockwise around the ring to number, because that will give the other chlorine a higher number. 1, 2, 3, 4, 5, and 6. A 1 and a 6. Again, that's silly. You know that by now, right? This is like basic organic that we are discussing. So chloro group down here in the bottom right-hand corner is spot 1, and that means that would be spot 2. So with the name, this would be a 1,2 dichlorobenzene. All right. Well, let's do another one. Let's do a benzene, and let's put a I there and an I here. Okay, we'll just change it up a little bit. That's all that we're doing. Just getting used to it, right? This is like our warm-up period at the gym. We're getting ready to go to the organic gym, and this is our warm-up routine. All right, so how do we name this? You name it the same. They're both iodines. So this is, yet again, another di-substituted benzene group. And in this case, there's 2 iodos. So I know that this is a diiodo. Now, I hyphenated this, but it is actually okay to do that number. And I know that looks kind of weird, like Wheel of Fortune would never allow this to happen on one of their puzzles, but it is proper to do that if you want. So diiodo, and it's benzene at the end, and they're both the same. So therefore, does it matter which one I start with? No, not really. You just pick one. So it doesn't matter. Just pick one. I'm going to pick the one over here to the left at the bottom. So which way do I number? Well, if I go up and over, this is a spot 2 and a spot 3 and a spot 4. And if I go down and around, this is spot 1, that's spot 2, that's spot 3, and that's spot 4. So no matter which way I go around the ring, I'm going to get a 4 as a location. So it doesn't really matter here. So the numbers here in front are going to be 1,4-diiodo-benzene. Now, this is IUPAC. The IUPAC is a system that is in place that really puts everything black and white as far as the rules go. Not all the time, but many of the cases we can use IUPAC rules and we can figure out a name just like we did here. I mean, there's nothing new that's happened here, right? Nothing new. We just use the IUPAC rules that we've already learned back in 251 and now in 252 with benzenes, and we just kind of build on top of that. That's the great thing about IUPAC. But there is an alternative. There is an alternative on how to name these particular structures that you're seeing on the screen right now. And these are going to be using common terms. All right. So over here to the right-hand side, these common terms are the following. Ortho, O-R-T-H-O, meta, M-E-T-A, and para, P-A-R-A. Ortho, again, we're lazy, right? I mean, why do we want to write ortho every single time? We can, but why not just write an O? It's understood to be ortho. For meta, what do you think we're going to use? Huh, who would have thought? An M. And then for para, what do you think we're going to use there? Well, look at you. A P. You're already a pro. So ortho, meta, and para can also be used in the world of di-substituted benzenes. And only in the world of di-substituted benzenes. Because ortho, meta, and para takes a look at the substituents that are on the group, and they figure out, well, as far as they are concerned, as far as those two substituents are concerned, how are they near each other? Are they side by side? And do they hate each other like really bad neighbors? Or does it skip one in between them? And there's a house here and then an empty lot and another house that's built there. They get along a little bit better. Or has it skipped two of them in between? Is it a house and an empty lot and an empty lot and another house? Oh, those are great times to move into those subdivisions because you have very little neighbors to look through your windows and your doors and be nosy about everything that you want to do in your life. Well, ortho, meta, and para will describe those locations. For ortho, these substituents are beside of each other, directly beside of each other. So that means that these chloros are going to be ortho to each other. Okay? Just bear with me. Meta. Meta means that there's one carbon in between them. So out of the three options that I've done over to the left, the meta version is going to be up here at the top, the 1-3 position. The ortho is the 1-2 position. And the para is directly across from each other. They are directly opposite of each other. So there's two carbons typically, if it's benzene, in between them. So para would be represented down here at the bottom. Now, as an undergrad, this was kind of tricky for me. I really enjoyed the IUPAC because that kind of made sense. I didn't have to remember anything. I just looked at the groups, I identified them, I named them, and I numbered them. I mean, that's really all that I had to do with IUPAC. And then they threw this crazy common stuff at me, and they expect me to keep the ortho, meta, and para separate? And then my instructor tells me that this stuff here is actually used more often. Oh, no. Oh, gosh. Why? Why do they even go through the trouble of doing IUPAC if they're not going to use IUPAC? Why do they want to use these rules only to turn around and say, well, forget about the rules for now. We actually like ortho, meta, and para a little bit better. And the O and the M and the P abbreviation. That means to me, and that means to you, that you're going to have to get used to ortho, meta, and para a little bit more. It's not as straightforward, and it's going to be very easy to get these confused. I think that a lot of times people have para, ding, ding, okay. I think that people understand para. It's the ortho and the meta that they always get confused. So let me show you a trick that I did as an undergrad to help me remember what benzene nomenclature was all about. All right, so here is going to be my benzene ring. And here is my first substituent. I'm just going to write it up at the top. How do I remember ortho, meta, and para? How do I keep them straight? Very easy in my head without going through the trouble of studying and reviewing, because I've got better things to do with my time than to study and review all the time, especially in organic. Well, here's what I want you to do. O-M-P, Becky. Look at that ring. I mean, it is so big. Okay, so if you grew up in the 90s, I think that you understood what I just did. And if you grew up in the 2000s, just turn to Nicki Minaj. She actually redid that song. O-M-P, Becky. Look at that ring. I mean, it is so big. So that is the order of the substituents. O-M-P. Yeah, you know me. Down with O-M-P. Yeah, you know me. Maybe those are for your 80s kids again. So this, if another substituent comes on, would be the ortho position. They're side by side. This one, if another substituent comes on, that would be the meta compared to this one. That's what we're comparing it to every single time, the one up here that's going to be starred. And then this one that's directly across from each other, if there was another substituent there, that would be the para position. OMP, Becky. There you go. That's the easiest way to remember ortho, meta, and para. So we're going to have to use these in our nomenclature rules, and this is how we do it. So let's go back and take a look at those other benzenes that we kind of talked about. I'm just going to do them in just whatever random order that I'm going to write them up here with. All right. So we've already said that this was 1,2-dibromobenzene. All right, so there's IUPAC, but what if I wanted to common name this? All right, well, I'm going to identify this one as the group that's in reference. So there's my first one. So OMP. So this is right next to it. O. This is ortho. This is going to be a ortho. That represents and takes the place of the numbers 1, 2. Dibromobenzene. If I don't want to write the entire ortho word out, I do O. O-dibromobenzene. There you go, folks. That's how you do the common nomenclature with di-substituted benzenes. All right, so let's take a look at another, and let's do bromo here and bromo there. I'm going to identify this one as my first one just because I can. It doesn't really matter. It's kind of like naming it. We've already said that this was spot 1, 2, 3, and 4. So we already said that this was 1,4-dibromobenzene. All right. Well, O-M-P, Becky. So that looks like this is a para position. So para, dibromo, benzene, and then if I want to shorthand it even more, I use the P, dibromo, benzene. There you go. That's it. Benzene. Let's do an I here and an I here. What about this one? How would you name it? Okay, well, identify one of them. Doesn't really matter. I'm just going to start up here at the top. They're both the same, so who cares? And this is spot number 1, number 2, and number 3. So this is a 1,3-diiodobenzene. If I don't want to use this 1,3 terminology, O-M-P, Becky. So that is the M, which would be meta. So this is a meta diiodobenzene. I can shorthand that even more. As you can imagine, I can just write an M, diiodobenzene. And there you go. That's how we common name di-substituted benzenes. But folks, this is not yet over. And the reason that I'm saying that is because in every single one of these cases, the groups are identical. So there's got to be more to the story. You know that that's coming, right? You know that there's a chance, a very strong chance, that these two groups are not going to be the same. They're going to be different. So how do we handle that? Is there a rhyme or a reason? Is there a set of rules to follow when we see benzene rings that do not have groups that are equivalent on them? And you know what the answer to that is. The answer is yes. You know there's going to be a set of rules that you got to follow. But this is the beginnings of naming di-substituted benzenes. OMP.